But in the very long future, once the universe will age by a factor of 10 or so, all the galaxies that we see will not be visible to us anymore.
So when you say the solar system, when you say not the solar system, when you say the universe is expanding,
right,
and that there is no edge,
right,
what is beyond? I want to go all the way back to when we were talking about the universe expanding and the Big Bang. I've heard this so many times. I've watched so many videos, and I'm just, like I said, I am fascinated with this. But how is it that we're able to know that it's, have we found the edge of it?
By the way, just a comment, footnote. I'm in the trenches. I'm doing science. I write a few papers every month. There are some people who publicize science, claim that they are defending science, and if you check their record, they haven't published a single scientific paper over the past decade. It's similar to commentators that are watching a soccer match and telling the players how to pass the ball. I'm one of those players. How dare they, when they criticize me, not doing any science, how dare they represent science? So that's just a side comment. But coming back to your question about the universe, there is no edge. We haven't seen any edge. So again, think about this balloon that is expanding. It has no edge. You can walk around the balloon, but there is no edge to it. And space itself, as far as we can see, all the way to the time of the Big Bang, as far as we can see, the conditions were the same everywhere, to 1 part in 100,000. And moreover, we can also say what lies beyond the region that we can see. The region that we can see is the distance that light traversed since the Big Bang, 13.8 billion years ago. So as I said, we can reverse the movie backwards and we calculate the time that elapsed since the point of that Big Bang singularity. It's 13.8 billion years. And gladly, we see that everything in the universe is younger than that. We haven't seen anything older than 13.8 billion years. So it hangs together. We have a lot of evidence that shows that everything started 13.8 billion years ago. We can even see the radiation that was left from this early hot and dense phase. It's called the cosmic microwave background, discovered by chance in the 1960s. But the point is, everywhere we look, we see that the universe started the same, to 1 part in 100,000. And even beyond the region that we can see, if you go to a distance that is 4,000 times bigger, the conditions must have been the same, because if there was a cliff, if there was an edge, it would have affected what we see. Okay. So we can tell that not only that there are 1 trillion galaxies like the Milky Way in the volume that we can see, but also beyond that, if you go 4,000 times farther, conditions must have been the same. And the other thing to keep in mind is, as we go deeper into the universe, we see light that was emitted at an earlier time because it had to make the journey to reach us by now. So we can see actually photographs of the universe when it was younger.
Wow.
I mean, when you look at a mirror, if it's, let's say, a few feet away from you, it just takes a few nanoseconds for the light to cross that distance. So in principle, you are looking at an image that is younger than you are because the light bounced off your face, went to the mirror and back to your eyes some time ago. So you're looking at yourself at a younger...
So you're looking back in time.
Yeah, but if you put the mirror a light year away, then you would see yourself the way you looked 2 years ago because of the time it takes the light to go from your face to the mirror and back. And we can look all the way back to the beginning of the universe, so we can see how the universe looked like earlier. And it all hangs together to an extreme precision at the level of percents. So we have a lot of data by now that is fully consistent with this picture. And the only problem is, if we calculate what will happen in the future, it looks very lonely. We will be left in our own galaxy with the stars that are in the Milky Way. Actually, also the stars of the nearest neighbor, the Andromeda galaxy, will join us within a few billion years. That galaxy is heading on a collision course with the Milky Way. I wrote the first paper calculating what will happen. The night sky will change, because right now the Milky Way is a disk of stars and gas, and our sister galaxy, Andromeda, is similar, but when the two will collide, the stars will mix in their orbits and will make what is called an elliptical galaxy. So the night sky, a few billion years from now, will look very different. The sun will still be around, but we may be tossed away from the center of the combined galaxy, which I termed Milkomeda. But in the very long future, once the universe will age by a factor of 10 or so, all the galaxies that we see will not be visible to us anymore.
So so many questions.
Okay.
If the universe is expanding and everything's moving farther and farther apart from each other, how are we going to collide with another galaxy?
Oh, excellent question. It's just that this Andromeda galaxy was made in a region that was quite dense, and it's not following the cosmic expansion. So you can ask, why aren't atoms expanding with the universe, or why isn't the solar system expanding with the universe? The answer is that it's held together by a force that is far greater than the repulsive gravity that is causing the accelerated expansion of the universe. So systems that are bound by a strong force, they don't care about the cosmic expansion. You need to go to very large scales of millions of light years before the cosmic expansion rules the behavior of objects. And that's why in the solar system, we don't need to lose any sleep about the expansion.
So when you say the solar system, when you say the universe is expanding,
right,
and that there is no edge,
right,
what is beyond?
We don't know.
So the farthest we can see is back in time to the beginning of the universe?
To the Big Bang, that's all we can see. And we can infer that conditions are similar to what we see out to a distance at least 4,000 times bigger than what we can see. But beyond that, we have no clue. And
so does that mean the way I thought about this 30 seconds prior to you talking about this was that I envisioned, because I've heard we have multiple universes.
Okay, so here we come to a situation where some scientists are not following the scientific method, in the sense that they are saying, okay, obviously we can't get any data or evidence about what lies beyond the region that we can see, but let's speculate. So maybe there are many other regions of space where conditions are quite different. It's called the multiverse. And maybe anything that can happen will happen an infinite number of times in other places. Now, why is that a good idea for some people? Because if you are a student and you get a D in an exam, then you can say, well, that's not a big deal because there must be another region of the multiverse where I get an A. If anything that can happen will happen an infinite number of times, I shouldn't be distressed about what happens right here, right now. So it takes away responsibility from people. And I have a problem with that because we have no evidence that such regions exist. But it became a very popular idea because if you use quantum mechanics, you can make the case that very early on in the universe, the conditions that we have in our region of space, there could have been many other regions with very different conditions. Because of quantum mechanics, the conditions could have been very different. And as a result of that, anything that could happen will happen an infinite number of times if space is infinite. I have a problem. This is a speculation. Nevertheless, it's popular in the mainstream of theoretical physics.
No matter where you're watching Shawn Ryan Show from, if you get anything out of this, please like, comment, subscribe, and most importantly, share this everywhere you possibly can. And if you're feeling extra generous, please leave us a review on Apple and Spotify podcasts.